folks, and welcome to Maths and Physics for You. Now we continue with what we started in the previous video about geometric sequence, and we saw how we got the formula to find any term in the geometric sequence. But now we continue with geometric series. What is geometric series? It's the sum of all the terms in the geometric sequence. So we saw that this is what we write. S means the sum for all the terms up to n. So starting at A, the second one is AR. That is the first term times the constant ratio plus AR square plus AR cube plus ARn minus 1. Because this is what we saw in the previous video, that the nth term is given by this formula, ARn minus 1. So this one gives you any term in this geometric series. Alright, now assume we want to find the sum, as in compound interest rates. You are interested to find the total value, not how much you are paid each installment or each term. So the sum is given by this, Sn equals A, that is the first term, multiplied by R, the ratio, the bar n, okay, the number of terms, minus 1, close bracket, over R minus 1. But we use this formula only if R, the constant ratio, is greater than 1. So this is the formula if R is greater than 1. That is, if you have R equals to 2, 3, and so on. So that it gives you, if you look at the denominator, R minus 1, if R is greater than 1, then you will have a positive denominator, always. So, but if R is less than 1, for example, if it is half, then we use the second formula, which is very similar to this, but the difference is that we have, instead of R minus 1, we have 1 minus R, and here 1 minus Rn, so that the denominator is again positive. Okay, so with that in mind, let's do an example. First example here. For each case, we have an example. Okay, let's look at this sequence. So this is a sequence: 3, 6, 12, 24, 48. Again, as you can see, A is a 3, the first term, and each number is obtained by multiplying the previous one by 2. So 3 times 2 is 6, 6 times 2 is 12, and so on. So R is 2. So that's what we look at. R is equals to 2, so it's greater than 1. If it's greater than 1, so which formula we should use? We should use formula 1. That is this one. This is first one. So in this case, this is the one that applies. Formula 1. Okay, easy. So this is, we want to find the sum of the 5 terms. So we have 5 terms. 1, 2, 3, 4, 5 terms. That's why we write S5, the sum of the first 5 terms. So A is a 3. R is 2, so 2 to the power 5, that's 5, minus 1 over 2 minus 1. Denominator is 1, 2 to the power 5 is 32, so we have 32 minus 1, multiplied by 3, 3 times 31 is 93. So that's the sum of the first 5 terms, but this is very easy to verify. If you add all these, that's what is you're going to get. It's easy, you add them. Okay, 48 plus 12 is 60, and that will give you 30 plus 3, 93. So that shows that this formula holds true. But you can use it to find the sum even up to 100,000, so that's the beauty of it. It saves you a lot of time and more accurate. Now let's look at the second example. Now we have this 2, 1, half, quarter, 1/8. So what is R here? the common ratio. It's half. Because to get 1, you multiply 2 by half. Then you multiply 1 by half, you get half. Multiply half by half, you get 1 over 4, and so on. And the first term is 2. Because this is r is half, it's less than 1. So what we do, which formula we use? We have to use the second one. So we go back to the second one, this one. Okay. That's the formula that we should use for the second example. Okay, again, so it is a into this time, we have 1 minus r, 1 minus rn. So 2, first term, 1 minus half to the power 5 over 1 minus half. Okay, denominator now is positive, it's half. 1 over 2 to the power 5 is 1 over 2 to the power 5, which is 32. Multiplied by 2, simplify, that gives you 31 over 32, multiplied by 2 over half. If you simplify more, that will give you 3.875, or 3 and 7 over 8 in a fraction. And that's easy also to verify by looking at the sum, because this is, they are very small, they are, easy to verify here. Because 1, 2, 3, 4, so 2 plus 1 is 3. And if you add these fractions, it's going to give you altogether 3.875. And this is the formula you use no matter how many terms you have. And I hope you enjoyed watching and benefited, and we'll see you in the next video. Please subscribe. Thank you.